Mr. Eric, Mr. Ryan, how are you today?
Good.
Okay, so today we're going to talk about an interesting subject, which is called longest increasing.
Subsequence.
Yeah, how do you know subsequence?
We watched the videos before. Yeah.
Okay, so let's do an example. Do you understand what's the subsequence?
You take none or more.
Okay, so for example, Eric, E-R-I-C, what's the subsequence? Can you list a few subsequence of the Eric?
Rick.
Sorry?
Rick.
Rick? Yeah, write down. Dick, egg. Yeah, there are lots. Even Eric is a subsequence of Eric. Yeah, because you're allowed to take nothing. Yeah, and Ryan, what's the subsequence?
Yan.
Yan, Ran,
Ran.
R-N, yeah, R-A, okay? Even R-Y-A-N, okay? Separate. So basically, you are allowed to erase nothing or erase anything, or you can erase all. So empty string is a subsequence of Ryan, okay? In technically, okay? Yeah?
Yeah.
Okay. So now, given an array with numbers, integers, yes, let's say 0, 9, 8, 10, 2, 4, 5. What's the longest subsequence?
0, 8, 10, 0,
2, 4,
5.
Sorry? Sorry?
0, 2, 4, 5.
0, 2, 4, 5.
1, 2, 3, 4, 5.
Because
7.
There's no 7. 0, 2, 4, 5. So there are 4 elements, yes? Alright? Can you find longer than that? No? Probably no, yeah?
No. How about 0, 9, 8, 10, 2, 4, 5?
No, because when you pick 9, you can't pick 8 because this is not increasing, this is decreasing. Yeah, got it?
Yep.
So it's always increasing 0, 2, 4, 5. Right? So therefore, so our task is to find the longest, to count the number of longest.
6, 7, it could be more. 7.
Longest increasing subsequence, so that will be the 4 numbers.
1, 2, 3.
Yeah, right, Ryan.
5, 6, 7.
Yeah. Do you get it? So the longest subsequent will be 4 elements, okay?
Yeah.
So any idea how are we solving this problem?
Just mind the longest subsequent.
So yes, how are we doing this? Any ideas? Just think about it. How are we doing
You
this?
got think about
Sorry?
it.
Sorry?
Nothing.
Any idea how we solving this?
Brute forcing.
Brute forcing, yeah, that's a good source. How are we brute forcing? So we find out every possibility of the subsequence, right?
Yeah.
And then we find if it is increasing, right? Yes?
Yeah.
So remember, the subsequence, the time complexity of choosing the subsequent is, for example, like let's say A, B. How many subsequents you can pick from two numbers, two characters?
4.
4, yeah?
Yeah.
How about ABC? How many? How many possible subsequence of ABC? Three letters. 2 is 4. Yes, that's right. 2 is 4. 1 is what? 2, right?
2.
Because you can pick or not pick, right? 2 is 4. Yeah, and 3 is what?
6.
How is that 6? ABC, A, B, C, A, B, A, C, B, C. And what? A, B, C. So it's more than 6, right? It's already 7. Yeah, and then you can pick nothing. Yeah?
8.
8. Yeah, so do you get it? And 4. Do you want me to tell you?
Wait.
Come on. 2, 4, 8. What's next?
16.
Yeah, so why is it? Look,
If you just double it.
double it. Why this is the total number of the subsequence or of an element? Alright. Look, because for each one, you can choose to pick or don't pick in the subsequence, right?
Yeah.
So for each letter, how many possibilities? How many possibilities for each one? So you pick or not pick, how many possibilities, Eric? How many possibilities? For A, I want to pick or not pick. How many possibilities? 2. I want to pick or not pick. How many? 2. So it's 2 times 2 times 2. How many? N times. So 2 to the power of n, right?
Yeah.
Yeah? So that's the total number of subsequence. Yeah?
Yeah.
In other ways, because n numbers, yeah? So the subsequence could be length 0, could be length 1, could be length 2, could be length 3, right?
Yeah.
And then do you still remember the combination, yeah? If Cn0 means picks nothing out of n items. And then picks one thing out of n items. Picks two things out of n items. And picks n thing out of n items, yeah? Because that's only one possibility. This is only one possibility. If you add all these, what's the total number of the subsequence? If you add all these. I just told you. What's this?
Subsequence. No. 2 to the power n.
Yeah. I was just checking if you're listening or not, okay? You're paying attention or not, okay?
I am.
Yeah, okay, that's good. Okay, so the blue forcing. Yeah, you come here. The blue forcing, wait. Blue forcing complexity O to the power n. And what's the complexity if we are given a subsequent? We want to check if it's strictly increasing. What's the time complexity of given a subsequent like 1, 2, 3? If you want to check 1, 2, 3 is strictly increasing, what's the time complexity? If there are n letters in the subsequence.
N.
Oh, n. Yeah, well done. So the overall time complexity is O to n times n. Yeah. This is very huge. This is highly complex. So it's not feasible to solve using the computers. Okay. Yeah. If n is 100, 2 to the power of 100 is huge. You know. Okay. So. Sure, we need to find a better algorithm. So how about I tell you that this problem we can solve it using dynamic programming. So what's dynamic programming? Can you tell me?
Remembering.
Yeah, the key thing is remembering. One of the things, remembering.
Memorization.
Yeah, that's even better. Remembering is the common word, but the memorization is the technical word. Okay, memorization.
It sounds quite funny.
Yeah, it's very similar to memorize, but it's memorization. Memo. What's memo?
Memo.
Memo is like a notebook. You put the notes in it. It's like your
It's
memo.
like a fish.
Yeah?
Fish. Name.
No, okay. So memorization. Alright. So dynamic programming, we are remembering. How about if I tell you that Fn, okay, Fn is we studied Fn is the longest subsequence, the nth number. So F2. What does F2 mean?
F2.
0, 1, 2. So it means that F2 means the longest number of subsequence, increasing subsequence. Then the last number is 8. Yeah? Okay?
Yeah.
Okay, so now if I know F2 is F2, I know F2, okay? And then here, look, because A is smaller than 10. So what does F3 equal? What does F3 equal? F2, I give you, we currently don't care about its value, but I know A is smaller than 10.
Yeah.
And then F3 is F2 what? You see, this is the F2 is landing. There may be a million items before A, yeah? But I tell you the number of longest increasing subsequence, that the last number is 8 is F2. And then now you know A is smaller than 10. So what does it mean for F3?
10.
Sorry? No, F3 is the number of the longest increasing subsequence that ends in 10. Yeah? And then now I tell you F2 the value is calculated. We already know. We already memorizing it using the dynamic programming memorization. And then I tell you A is smaller than 10. So what happens if I add the 10 in the longest subsequence? Does it still valid? Yeah? Because look at the last number ending in A. Yeah? It could be 1, 3, 4, A. This is a subsequence. previously. Yeah, you don't care. And then now you know A is smaller than 10. What happens if I put a 10 here? What happens if I put a 10 here? Does it still make a longer one? Does it make sense? Do you get it? So F2 equals F2 equals what? F2.
Equals.
I put the 10 in the end. It's still a longest subsequent. It's still a increasing subsequent. Yes, F1. That's what I meant. Okay. You get it?
That's one add. No,
Yeah?
and one.
Yeah, one added. Do you understand? Yeah?
Yeah.
And do you see, because we already know this bit and we can reuse it. Yeah? Why can we reuse it? Because A is smaller than 10. Yeah? And this bit, for example, a million, if F2 is a million, and then I know F3 is a million plus 1, because I can always put a 10 at the end of previous longest subsequence, and you will increment the longest subsequence by 1. Got it?
Yeah.
Got it? Yeah?
Yeah.
So if I want to check this F3, so I need to check every number between 0 to 3. Look, I want to check every number between these. And I check if 0 is smaller than 10. If it's smaller than 10, then F3 equals 1 plus F0. But I want to get a maximum of these, okay? And then 9 is smaller than 10. Yes, then 1 plus F1. A is smaller than 10. Yeah, F2 plus N plus 1. Yeah, got it? Okay? Do you understand? Yeah? Yeah? A kind of, maybe it's better if I write a code and then you will see how it works. Okay? Let's say define. Remember the top down and bottom up dynamic programming. Yeah, there are two approaches. Yeah. What's top down dynamic programming usually implemented in what? Top down. If I want to calculate Fibonacci number every time I talk about Fibonacci number. If I want to calculate the F100 Fibonacci number, what do you need to know to calculate F100? You need to know F99 and F98 because it's the sum of previous two, right? Yeah? Okay, so the Fibonacci number F99 and F98. So this is top down because I want to calculate F100. I need to recursively calling. Yeah. I need to recursively calling F99 and F98. Am I right? And then bottom up dynamic programming. What's that? If I want to calculate F100, where do I need to calculate first? The bottom up.
You need to calculate
From the other direction. What's the other direction? Bottom up. And where is the first value I need to calculate? Where's the first value?
F.
F for what?
I. No, Fn. N.
No, I want to calculate Fn. If top down, if I Fn minus 1 plus Fn minus 2. Okay, this is called top down because I start with n and going down. And if I want to do it bottom up, I need to start with what? Start with what?
I.
This direction what?
Vertical.
Come on, n
Up.
n to 0, and then what's this?
N.
What?
0.
And I want to start
0
calculating.
to N.
Yeah, so I need to calculate F0, F1, and then using these two values to F2, right? This is called bottom up. Do you understand? Different direction, yeah? Basically, it's the same thing, yeah? Okay, so look, define Fn. Fn, okay? So look, Fn is the longest number, longest increasing subsequence of the nth number, okay? Yeah? Got it? Got it?
Answer.
Yeah?
Math equals something.
yeah, answer equals. So look, the longest subsequence, the minimum value is what? Is the, if I have only one value, what's the longest increasing subsequence? 1, for example, if I...
1!
Yeah, because it's one value, it's increasing, okay?
Yeah!
Okay, so look, then for I in range, I need to check the values up to nth, right? So let's put the n here. Look, if Eric, look, this is
Yo.
numbers. If numbers, okay. So suppose we have numbers here, okay. Numbers I is smaller than numbers.
That needs to be a proper J, G, G.
Okay. If I number smaller than number n, look, answer equals max answer, okay? Eric? Answer. And what should I put here?
Cash.
No, not yet. F what? Eric?
J. J.
There's no J. I here. I is in range n. If I look at it, remember this is I, this is I, this is n. If this number is smaller than this number, yeah?
Yeah.
And then what should we do? Answer will be the maximum of what? F what? F what? We calling it F. Fi, yeah?
Yeah. I said I.
Add what? Add what?
1.
Add 1. And return what?
Answer. Yeah!
Okay, what's missing?
Cash.
Cash. Yeah, because if we're not using the cash, these will be exponential, yeah? We need to, for each Fn, we only calculate it once, right? Yeah?
Yeah.
Because the next time we don't need to calculate it. Okay, this is called what dynamic programming? Top down or bottom up?
Top down.
Top down. Okay, yeah, because we calculate Fn and we go in recursively. Calling.
Careful, bottom up.
Yeah, then we calculating from I from F0 to F1. Okay? Yeah. Okay, so now another one. And remember, we can declare a notebook. Yeah, without the cache, we can use this what? We can use a notebook passing as a parameter,
Yeah.
and then if n in notebook, return notebook n, right? And before we return it, we can store the values in the notebook. Okay, something like notebook n equals value, and return value. Yeah, remember, return value. Yeah, define f n notebook, and you can using what? Using a set. Yeah. Not the set, the notebook dictionary. And look, if n in notebook, return notebook n, right? Because look at, you need to write this. It's better we just get rid of everything and do this magic keyword, which is
Cash.
cash. Okay, cash.
It's
Okay.
money.
Not like cash. Okay, let's do this again.
Money juga.
Longest. Let's
Language.
look at Fn column, yeah? If, let's say, no, not n, numbers, yeah, numbers. And then n equals length. We need to find out the numbers first, the length first. If n is 0, return 0, yeah, because, and if n is 1, return what? If there's only one element in the array, what's the longest subsequence?
2.
No? If there's only one element in an array, what's the longest subsequence? Longest increasing subsequence. If there's only number 1.
1.
1, yeah, 1. Okay. Now we need to store these arrays in the dp values in an array. No? Let's say dp equals, beginning will be 1, right? Yeah?
Yeah.
Because each value will be, the longest increasing subsequence that ends at each number is at least 1, right? Yeah? Am I right?
Yeah.
Times n plus 1, okay? Times n plus 1. Okay, then for I in range n, right? Then we do another loop. For j in range I. Okay, so basically look, this number, okay, Eric? This is the number 0 to n, okay? To n plus 1, okay? Eric? Look. And then I will be here. When we know I, this is value, we start from j. J will be this point, yeah? Do you get it? So look, when I is 5, am I right, Eric? Look, when I is 5, j will be 0 to 4. When I is 10, j will be what? J will be the range of what?
Will be 0 to 9.
We're done. Okay, so This is basically give the complexity of
N.
There's 4 over
N times N.
n square, right? Or quadratic, yeah? Quadratic. Okay, look, if Z, then we always do. If nums, if nums smaller than nums I, what should I write here? Can you write this bit? If this number,
Return.
Eric,
Return nums.
if A is smaller than 10, so what should we do? We should update.
Return.
Not yet, we need to fill the value, dp what? Look, if A is smaller than J, this is Z, this is I. If numbers J smaller than numbers I, then we need to update dpi equals maximum. You need to do the maximum dpi. It's the same thing, and dp what? dpj what? F1. Okay. And then return what? Return what? Return what?
DP something.
Okay, so the return, but look, dp is the dp1 is the number the longest subsequence that ends the number I, right? Number 1, right? So we need to find the maximum value of the all dp value, right? dp0, dp1, dp2, dp3, yeah? Am I right?
Mm-hmm.
Got it? So it's not the last element. Okay, so we should return max dp. So it's all the values, the maximum value in the dp array. Do you get it?
Yeah.
The previously that one was kind of mistake. Okay, let's write it again. So just to give you a define fn, right? And then cache, yeah, cache. Suppose we know the numbers here, okay? But if n equals 1, return 1, right? If now we do this answer equal 1 for I in range n. Yeah?
Yeah.
Answer equals what?
Answer equals
Max answer. No. We need to check if num I smaller num n, right? If it's smaller, then we can say answer equals max every answer, and that will be fi what? Fi what?
Fi.
If this I is smaller than n, so this answer currently will be what? Will be what?
FJ.
There's no J, there's I, this is N. F what?
I.
Fi plus what?
+1.
Plus 1, yes. Don't look at my notes, it's slightly different, okay? You need to understand, okay? You need to understand before you know the answer, okay?
Just guess before.
Yeah.
Yeah.
Look, this is the procedure Fn, and when we're calling it, we need to return what? Maximum of fi for I in range n, right? Because Fn, look, because this Fn is the longest increasing subsequence that ends the nth number, right? Right?
Yeah.
So it's not the answer. The last element is not the longest increasing subsequence.
24 minutes.
The longest increasing subsequence is not needed to be including the last element. Am I right?
Yeah.
Do you understand? So you be the maximum of fi where I is from what? From 0 to n. Right? Alright, look. 2, 3, 4, 5, and then let's say 10. How can we do the last element. 5, 9, 10, 11, 2. Okay, what's the longest subsequence? Harry? What's the longest subsequence?
5, 10, you can think of.
Yeah, 3, yeah. Okay? So look, this F0 is what? F0 is what?
F0 is 5.
The longest number, not 5. This is num. Num's array. Num 0 is 5. But F0 is what?
F0.
The longest increasing subsequent that ends with number 5. How many?
1 to 5. No, 1 to 4.
Do you get it? What's the longest? What's the number of the longest subsequence that ends in number 5 in this array? What's that? What's it?
End.
The ends in number 5. How many? What's the longest increasing subsequent that ends in number 5?
2.
Why is it 2? Why is it 2? Starting from left. Why is it 2? What's the answer? Ends in number 5. Can you find any longest subsequent that ends in number 5? Ryan? What's the longest subsequent? Sorry?
10 and 11.
No, I mean something 5, not starting with 5. Ends with the number 5.
2, 5.
Sorry? Why you don't understand?
5, 10.
The ends, you don't care about the rest. I mean, say any number that longest subsequent that ends number 5. How many?
4.
Why is it 4? Come on. You still don't understand. What's the longest subsequent that ends in number 5?
1.
1. What are you thinking? That ends in number 5. What's the number? What's the longest subsequence that ends number 10?
1.
Why is 1? No. 2, 5, and 10. Got it? Okay, what's the number that's coming that ends in number 11?
3.
Yeah. What's the number that's coming? Sorry?
4.
Why is it 4? Can you find the 4? You not just say 1, 2, 3, 4. What's this? What's the longest subsequent that ends in number 2?
1.
1, yes. Because you cannot find anything. Do you understand?
Maybe it could be 1, 2.
Yeah?
Yeah.
Okay, so what's the longest subsequent in this array? Is it 1? It's not 1, right?
3.
That's why we're not picking the last value, right? We pick all the best value, highest value in this array. Got it? Do you understand now? Do you understand?
Yeah.
Just to give you, that's why look, we check all the value. If numbers I is smaller than numbers j, then we update it. This is dynamic programming, the spirits of dynamic programming. Okay.
Yeah.
So look, I'm writing another sequence. Okay, 3, 5, 7, maybe 3, 5, 1, 4,
Been 28 minutes.
0. Okay. Can you write the f value? F0, okay, F1, that's a teamwork, you too, okay, F3, F4,
And F5.
F5, and then tell me,
F5 is 0.
and then tell me,
S 1.
and tell me what's the longest subsequence, longest increasing subsequence of this question, and then we can end this class. Can you do it,
Where's
please?
F3?
F3, yes, thank you for reminding me, okay, F3 here. Okay, can you write it, please?
Whoa. But that's definitely 1. There's 6 of them, and there's only 5 numbers.
Okay, so, sorry. Okay, so F0, F1, F2,
Out the way.
F3, and
That's
F4.
1. That,
Can you write it? Feel it.
I need
Come
to
on.
plan one.
Okay, just feel it. Come on.
1. Is it definitely 1? Because it only could be 0.
You can do it. Eric, do you need a pen? Come on.
4. I already have a pen.
Okay, then come on.
1, 2, 3.
The longest subsequent it ends with this number, this number, and then this number.
So
Okay.
the first one is definitely 1. This one is definitely 1.
Okay, that's correct.
Confusing.
Yeah, this is correct. Okay. And what's this? Come on, feel it. Come on.
Use a red pen for long.
Yeah. Okay, so you got a 1 score. Okay.
1 out of 5.
Come on, I give you a mark.
1 out of 5.
Okay, come on. Yeah. Everyone, come on.
1, 4,
What's F0?
The one before which are smaller.
Yeah. The one before are smaller. The longest you can find. The longest subsequence.
So the first one's 0. No, this one's 0.
Well, there is no 0. The minimum is 1. Come on. You can start with the number. Yeah. So what's number?
1.
Write it. Okay, correct. F2. F1.
2.
Write it.
2.
Why is 2? Can you give me a... Because what?
5.
3, 5. Okay. And this one?
1.
Yeah, write it. Why is 1?
Because the 1.
This one. You can't find anything that connect with, end with number 1. Okay, F3?
F2. Wait. I think it's 2. I don't know. Wait.
Ends with number 4.
1, 3.
No. You can't go backwards. Come on. What's this? Yeah?
I think it's 2.
2. Yeah. Be confident. Come on. Write a 2. Okay, so what's the longest subsequence here?
2.
2, because you find the maximum value of this, yeah? Yeah, do you understand how this problem is? Yeah?
Yeah.
Wait. Look, the big...
Being more than half an
That's
hour.
okay. Look, 1 is smaller than 4. So we know F3 is F2 plus 1. Am I right?
Yeah.
Yeah, do you get it? Yeah? Eric, suppose we want to calculate F3, right? Yeah?
Yeah.
Because 1 is smaller than 4. So we know it's F2 plus 1. At least it's F2 plus 1, right? Because F2 we know it already.
Wow.
Okay? Got it? Yeah, okay, so, okay, that's it. Say bye-bye to people. Say bye-bye.
Bye.
What happened?
Nothing.
You need to say thank you and see you tomorrow.
Thank you. Thank you.